The difference between a good batsman and a great one often comes down to just 5 runs in their average. Today, we will learn about descriptive statistics using averages and economy. This is the deliveries.csv file. Let's get started with averages first. What is an average? Well, how will you explain away thousands of rows of data into a single parameter? Well, one of those parameters is the average. It is arithmetically calculated middle line. Other parameters which are similar to averages are median and mode. Now we can use these parameters to find out how well a batsman is considering a few or all of the matches. Median is the middle one of all the scores listed of that batsman, and mode is the most frequent scores of that batsman. In order to assess all of the batsmen, I am using the 2021 to 2024 to consider only the latest form of the batsman. We will first VLOOKUP the date from the matches.csv file. If you do not know how VLOOKUP works, please tell me in the comments and I will make a video to simply explain that. We then convert this value to date format and filter out data from 2021 to 2024. Now this data is at a ball level detail. We want the data at match level for all the batsmen. We want to know how much each batsman scored in match by match, not ball by ball. Hence, we will have to pivot this table. You can press the shortcut Alt and then N and then V to open the pivot table, or simply go to Insert tab and click on the pivot table. We will need the match ID, of course, the batters and their total runs scored in that match. Put the total runs field into the values field. Go to Design, click on Report Layout and click on Tabular. Go to Subtotals and turn off all the subtotals. Now copy this to a new sheet. We need to fill these blank values, but how do we do that? We know that the value of blank match ID has to come from the value above. Assign the value of the second row to third row and copy that formula. This formula basically means that the value is being taken from the cell above. Now in order to select all the blank cells alone, we will select the whole column, press Ctrl G, go to Special and then select blanks. Now all the blank cells are selected. Now paste the value by pressing Ctrl V. So all the formulas will be pasted in the blank values. The formula is basically means take the value from your row above. Now since all the rows are filled, we have the complete match-wise data for each batsman. But what should be the final format of the table? Do we need match ID? No, we just need averages of each batsman considering all these matches, right? We will pivot this table again. We will choose the batter and drag the total runs to the values. Now right click on the total runs field and change the value field settings to mean. Now convert the format of this column to number using the ribbon in the home tab. Now drag the match ID to values column and change the values. Now change the value field settings to count so that we have the count of match ID as well. Now copy this to another sheet and format it. Add filter to this by selecting the whole data and pressing Ctrl plus Shift plus L together, or find it in the home tab, fifth from the left. Now filter for count of match IDs to be more than 15 or any number you desire. So a batsman has to play at least a 15 match or so to become eligible to be in our list, right? Now sort the averages of runs in descending order to see who are the top batsmen who has the highest of averages. Now these are the top 10 or 20 batsmen with highest averages. Devon Conway, Sai Sudarshan, KL Rahul, Butler, Faf du Plessis are some of the names. Just look at what you have created here. You have essentially found out which are the top batsmen in the IPL from 2021 to 2024 which has the highest of averages. But this is only one of the parameters to test a batsman. The second parameter, the median of the runs scored by the batsman. What is the purpose of median when mean can define a large data set? Well, mean has its own disadvantages. We will talk about this further. Go to the pivot table where we had batsmen and their averages. Drag the match ID to the column section as we will calculate median horizontally for each batsman. Now copy this and paste it into an Excel sheet and format it well. Simply use the formula median in the Excel and select the columns containing all of the runs of the batsman. I have hidden the columns to make it less cluttered. Put a filter on count of match ID and sort the median in descending order. There you go, you have successfully generated a list of batsmen with the best median. Now the third parameter, mode. As we have calculated median, we can calculate mode in the similar way. Only the formula would change. Instead of median, make it mode. Use the population parameter which is denoted by P and not S. And select the singular one. You will get NA which stands for not available because there may be rows with no repetitive data. Like what is mode? The highest frequency of a particular run scored. For example, batsman A scored 51 10 times or like 23 runs 10 times, which is very rare, right? That is why it is not beneficial to find mode in this kind of analysis. You can maybe try finding mode by splitting the runs into intervals. For example, how many times the batsman A scored runs between 0 to 10, 10 to 20 and so on. Now this is more of a right approach. Let us compare what does mean and median actually communicate. If the mean of scores is much greater than median, what does that mean? That means there exist outliers in the right hand side of the curve. That means there are only a few outstanding scores. In such cases, median is the closest accurate parameter. If mean of scores is much lesser than median, then the outliers exist on the left side of the curve, meaning there are only a few bad scores pulling the mean down. Using this, we can find batsmen who truly are the best in terms of scoring runs consistently. In the table where you have found median, just VLOOKUP mean from the table where you have found mean. Now calculate the difference between mean and median. Negative means median is greater than mean. Such batsmen have only a few bad scores. On the other hand, positive value means median is lesser than mean. Such batsmen have only a few outstanding performances. As you can see, Sai Sudarshan, Travis Head and Josh Butler have a few good performances. You can verify this claim by going to the pivot table and filtering for Josh Butler and then create a line chart of his runs. You can see there are a few good scores and more bad scores. Now compare this to Devon Conway, whose median is actually greater than mean. Plot his scores. You can see he has more good scores and more good scores than bad ones. You can compare both of these charts. But is mean enough? What about consistency? Consistency is measured by variance. As the name suggests, it measures the variability of the run scored by the batsman based on the mean of that data. More the variance, less consistent is the batsman. Variance is in square units, hence we will need standard deviation, which is basically the square root of the variance. Now go back to the second pivot table that we had while calculating mean. Now in the value section, you have kept average of total runs, right? Bring the total runs field again into the value section, but this time change the field settings to standard deviation of population denoted by P. Now copy this data to a new sheet and format it. But should we use only standard deviation to judge the consistency? Let me tell you what do I mean. Example, tell me which dataset is more consistent, the above one or the bottom one. Pause the video and think about it. Looks like dataset B should have more variance because it clearly is less consistent, right? But if you calculate, dataset A has more standard deviation. Why is it so? Because of the sheer magnitude of the data values dataset A has. Now to normalize it, we can divide the standard deviation by the mean to get a percentage of deviation basis the mean. If we incorporate this, we get the correct measure of the consistency. This ratio, by the way, is called the coefficient of variance. All you have to do is calculate for the first row, copy paste it for all the rows and convert the values to percentage from the home tab. Now filter for batsman who has count of match ID greater than 15 and average runs greater than 35. Sort the coefficient of variance in ascending order to see who has the least variance. Tada! You have the list of top batsmen with average higher than 35 and most consistent among other batters. Jason Roy, Devon Conway, Ruturaj Gaikwad, Virat Kohli, KL Rahul are few names in this list. Similarly, tell me in the comments below who are the top 10 batsmen who has best strike rate between 2021 to 2024 in IPL. And I will see you in the next video. I hope you're enjoying this course. Take care. Bye.